In this video, we are going to determine the equation of a sinusoidal function from its graph. This is very similar to what you did in the previous lesson. It's basically the exact reverse. So previously, I would start you off with the equation and you would generate the graph. So now I'm going to start you off with the graph and then you build the equation. So I wrote some steps here. So the first thing you would do is just study the scale. And then you can look for one cycle, and it doesn't matter if it's sine or cosine. Then after you identify the cycle, you identify the amplitude, period, and the shifts. Okay? So they want us to model it using sine and cosine as well. So you know what? What I'm going to do is find the A value, the K value, and the C value first. Okay? So let's say the magnitude of A, which is the amplitude, can be found using the max and min values, right? So the max value here is 1, the min value is -3, so 1 minus -3 over 2 is 2. Beautiful. Okay? Hopefully you can understand, like if I have A, K, D, and C, you know what, I can build the equation very easily, right? So I'm a quarter of the way there essentially. So what about the K value? Well, the magnitude of K, I really want to know the period. So I'm going to sketch in one cycle. Let's sketch in one cycle here. I'm going to start with sine. Okay, so sine in fact, I cheated a little. I knew this was halfway. How did I know that? Well, you can sketch in the equation axis if you want, but the C value is the average, right? Remember, it's the midline, so you want to average the max and min values. So, okay, with the max and min values, I can determine the A, the magnitude of A, and I can tell you what C is. What about K? Well, for K, I really want the period. Okay, so the period is 360 degrees. So, magnitude of K is 1. There's no horizontal stretch or compression. All right. So if you visualize this as a sine function, okay, then you can say that the D value is 0. If you visualize it using sine, then D is equal to 0. So f of x equals, and by the way, if this is the function I'm visualizing, and this is if I choose this as my starting point, this is the regular sine function here. So this would be 2 sine x minus 1. Okay. So did I have to choose this as my starting point? Absolutely not. So what else can we do? We can choose this as our starting point. Right? If you want to visualize it as a cosine function. You know, I'm going to run out of room. So if that's the case, I'm going to choose right here. Right? See? Another cycle. Okay? So if I started here, I'm visualizing this as a transform cosine function as opposed to transform sine function. But you know what? It'll be exactly the same. I'll use g of x. So if I start here, be very careful. Instead of a being 2, it's -2 because there must have been a reflection across the x-axis, because cosine usually starts at a maximum value. In order for it to start at a minimum, I must have applied a reflection across the x-axis. Okay, but luckily everything else is pretty, well, sorry. The K and the C values are the same, right? The period is still 360. And the C value, well, the equation of the axis is still y equals -1. But I did introduce a shift. I shifted, if you look at the graph, it's 90 degrees to the left. All right, if you want more equations, you know what? Let's keep going. Let's keep going. Why not? You could have started 90 degrees to the right. You could have started 90 degrees right. If you chose to do so, that's the equation you would have got. You could have chosen to start over here at 180 degrees to the right. But if that's the case, then A will be negative, right? Because you're now visualizing this as a sine function that's been transformed with reflection across the x-axis. So where was I here? This is -180 because it's 180 degrees to the right. Okay, so guess what? F of x, g of x, h of x, j of x, even though the equations look very different, they're all equivalent. They represent this graph. Okay, they all represent this beautiful graph here. So because of the periodic nature, because of the repetitive nature of this sine wave, you can pick an infinite number of starting points. Okay, there are truly an infinite number of starting points, and that's why I saved D for the very end. D is, I don't want to say confusing, but it's definitely the most interesting between A, K, and C. There are infinite number of D values, but in terms of A, K, and C, well, think about it. The amplitude of the graph is not changing, whether I visualize it as sine or cosine. So the magnitude of A is always going to be 2. The magnitude of K is always going to be 1, or whatever it is, because the period is unchanging, whether I visualize it as sine or cosine, regardless of where I choose the starting point to be. And the equation axis, well, that's always going to be where it is. So D is the, I don't want to say the problem, but it is interesting. There are an infinite number of values for D, so when I mark it, I have to be very careful. Before I say you're wrong, I have to triple check, because there are infinite correct answers here. Okay, so, you know, we're going to use that idea to do all the questions here. All right, so I'm going to start with A, max minus min, so 3 minus negative, oh, same thing again. 3 minus -1, max minus min, so it's 2. I'm going to solve for C this time. 3 plus -1, just like last time. Oh, wait a second. I see the issue. It's +1 instead of -1. Let me check the previous graph. Yeah, I see. The numbers are very similar, but slightly different. All right, so I'm going to sketch in, I'll do cosine first this time. And I always prefer to start on the y-axis if possible. If it's not possible, then obviously I won't, but in this case I can do it. So infinite starting points. So if you visualize this as a transform cosine function, you can start here, the max. You can start here, the min, or this max, or this min. Okay, so based on this graph, if you want to visualize as cosine, you have 4 starting points, 4 potential starting points. Okay, so what's the period here? It's 180 degrees, which means K is 2. You must have applied a horizontal compression by a factor of 2. That's the only way to get a period of 180 degrees. So I don't know what D is, but in this case, if this is how I visualize this, then D is 0. And it's -2 because you reflect it across the x-axis to get that the one that I drew in green. +1. So if you visualize this as sine, you know what, I'm going to start over here. so I can sketch in a full cycle. Okay, now here you might not know what it is, but based on our previous knowledge, I didn't even have to sketch it in, to be honest with you. I can tell what the value is, because to go from this minimum point to this point on the equation axis, I know the separation is a quarter period. And if the full period is 180, then a quarter period is 45 degrees. So this must be a 45 degree shift to the left in order to start here. So this is going to be -2 sine 2x of plus 45 degrees. So if you combine your knowledge from the previous lesson with this lesson, you know what? It makes it pretty straightforward. All right, so I could also start over here, but you know what? Why am I starting so far away? So generally speaking, to make our lives easier later on when we do the calculations, you want to pick a starting point that's on the y-axis. Now, if that's not possible, then pick a starting point that's close to the y-axis. Well, closer to the y-axis. The closer the better, I'd say. Okay? I've always, like I say to my son all the time, why are we working with big numbers when you can work with smaller numbers? If it's possible. All right. So, what do we have here? 2, oh, that's silly. The amplitude is 2, the C value is 0. Let's do K. What is the period here? You know what? I can already show you. I can imagine, so I can already see it's 720. But you know what? Let's go for it. So that's 720, which means the K value is half. And that makes sense because if K is half, it's a horizontal stretch by a factor of 2. What is D? Well, if I started over here, you know what? I could have started over here. But the reason I started here is so I can show you what the period is. So let's say I start over here. So that means a 360 degree shift to the left. So minus 2, because it's reflected across the x-axis. And then we have half x plus 360 degrees. And if it's cosine, I can't really sketch it in perfectly, but I'm going to start, let's shift to the left, why not? So a quarter period. If the full period is 720, what's a quarter period? 180? So let's start right there. I can't sketch in the full cycle, but I'll try my best just to give you a visual. Something like that, okay? So that's a -2 cosine of half x plus 180 degrees. All right, beautiful. Last one. So amplitude, max minus min. Max is 6, min is -2. 6 minus -2, that's 8 over 2 is 4. What about the C value? Average 6 and -2, that's equal to 2. What about the K value? I can't tell you because I don't know the period. Let's do here 20 degrees. That's pretty close to the y-axis. Okay, beautiful. I start at 20, I end at 140. What does that mean? The period, the horizontal length of one cycle, is 120 degrees. And that must mean you horizontally compress it by a factor of 3. What's a D value? Well, if I start here, that's 20 degrees to the right. And that's reflected cosine, or cosine reflected across the x-axis. So 3x minus 20 degrees plus 2. If it's a cosine, if it's a sine, because I already did cosine. Whoops, I meant to do the same color coding. It's okay. I'm sure you managed. So we'll start here. Okay, what do we have here? So if I start, that's -4 sine 3x, and it's 10 degrees to the left. And that makes sense because if you look at this horizontal distance between this starting point and this starting point, that's a quarter period, 30 degrees. Perfect. Okay, I think everything makes sense. So my strategy is between A, K, D, and C, A and C first, and then solve for K, and then identify D. Now there are infinite values for D, but try to keep it as small as possible. Best case scenario, D is 0. All right, so hopefully you can now determine the equation from the graph.